So in day 17, we basically had to simulate a Tetris game. So the idea is that the pieces that we'll have to simulate always repeat in the same order, and they are this minus shape, a plus, a reversed L, a vertical line, and a square. Then we will have the sets of inputs, which will be the direction that the piece will have to move to the right or to the left, and also this input will repeat itself after we are done. So then they basically show us an example of how the rocks are pushed around and how they fall down, and it's pretty much the same rule as in Tetris. So when the piece hits something on the floor, it remains there, and if it moves too far to the right or too far to the left, it doesn't move anymore in that direction. It just drops down. So for the first question, we want to know how tall this tower will get after 2022 rocks. And for the second part, the elephants are not impressed with only 2022 rocks, and they want this huge amount of number to be simulated. So yeah, so the input was pretty simple. I just created this enum for storing the direction of the push to the left or to the right, and I just went through each character, and if I found the left angle bracket, I return the left push, and if I found the right angle bracket, I return the right push. Then I have this helper method which applies the direction of the push on an x variable. Then I created this point structure, and I did because I wanted to have a comparable point, and we want to be able to compare the points by the y-axis because we are interested in the height after all. Then I implemented the piece as a vec of points, and I created a function that creates each type of piece. Like a horizontal piece will be just 4 points from 0 to 4. The plus will be like a plus, the L will be the reversed L shape, vertical will be the vertical line, and square will be the 2 by 2 square. Then I have this collision function for the piece that will check if a piece is in collision with the map. So basically the map will be just a hash set of points, and if any of the points that make up the piece are touching the map, then it's in collision. So we do that by subtracting 1 from the y value, and if the map contains the new point, then it means that it's a collision. So we return true. Then I have this gravity function that just subtracts 1 from each point in the piece. And finally the push function that first checks if the piece can be moved to the left or to the right, depending on what is the direction of the push, and if it can be pushed, like if all points are between 0 and 7, which means that they are inside the map, it means that we can apply the push on each point on the x field of each point. Then I have this piece spawner that will contain the counter so that we know what piece to spawn and also what move to make. It will also have a hash set of all the points that make up the map, like all the pieces that are stuck on the bottom and the bottom of the floor. And we will also have this top value, which is the maximum height that we reached so far. And yeah, we'll also need this heights field for the second part. Here I just created a two-string implementation for spawner just to be able to visualize the Tetris board. So initially the spawner will be just a hash set with the floor of the map. The counters will be 0 and the top value will be also 0. Then, I mean, because of the name, we have this spawn method that will create a piece, and yeah, basically they tell us that we have to spawn the pieces at location on x-axis 2, and on the y-axis it has to be at the top plus 4. Then we choose what piece to spawn, and we just create a new set of points, basically just create a piece. Then we have this drop method that creates a piece. Then we need to tell what input to apply on the piece, like what move, push it in what direction. So we first apply this push, then we check if we are in collision. If it's a collision, then we stop, and after that we apply gravity. So yeah, I guess this you had to pay a bit of attention and always do the loop like this. Like first you push the piece, you apply the input to the left or to the right, then you check for collision, and after that you apply the gravity. And then we compute the new top if there is one, because maybe a piece can fall around the entire tower and go to the bottom, but usually we'll get a new maximum value. And then we have to update the heights value. So basically in heights we add the new top minus the old top. So we use this vet as some sort of an identifier list of how much each piece contributed to the increase in height for the Tetris map. So basically we'll be able to use these values to find the cycle after which at some point the entire map will repeat itself. But yeah, I mean the idea is that maybe not the shapes itself will repeat, but actually the height differences. So it's better to look for this value, because I also tried to look at how the pieces repeat themselves, but I didn't find the cycle as good as using the heights values. And yeah, at the end we have to extend the hash set, like the Tetris board, with the current piece, because it got stuck on the bottom. Then I have this find cycle function, and the idea is that we will have to iterate through all the heights, and we'll have to find first an offset, because basically these heights, maybe they won't start always with the cycle. Maybe they'll have a small amount of random heights which will represent the offset, and after that there will be a window, some amount of size that will repeat itself. And I mean this is usually the case for AOC problems. Then for the first part we can just use the drop function. These are too few steps to be bothered to use something optimized, so we could have used this without using the finding the cycle or something. Just simulate for 2000 steps and you're fine. Just return the top value. Then for the second part I simulated 5000 steps. I'm not sure if there are inputs which require more steps, but I think that 5000 is enough. Then we try to find the cycle, and I mean yeah, if you don't find the cycle, just increase this number. And instead of simulating this huge amount of drops, we know that we have a cycle that we can apply multiple times. So first we have this init value that will be the initial offset. So we take the sum of those heights, and that will represent the beginning of the Tetris board. Then we have the cycle, so we get the sum of the cycle, and then we want to know how many cycles we will have in this amount of drops. So we just subtract the offset and divide with the window size, and this will give us the amount of cycles. But yeah, maybe we won't have a whole number, so we also have to do modulo on this amount to get the amount of steps that will be done at the end of the spawner, and that will represent like the end, like the suffix of the heights. So what we have to add together is the init part, the offset, then we have to add the cycle amount for cycles time, and the end amount which will represent the suffix. So yeah, basically this was the 17th day. Here I just wanted to show like the simulation of the first part. It gets quite large, but it's too large to fit on the entire terminal. So basically this was the 17th day. If you want, you can check the code, and see you guys next time. Bye bye.